So let's review everything we've learned so far with the method of undetermined coefficients. We know that if you have a non-homogeneous term, g of x, then you should guess a particular solution that's of the form of like g of x, and this guess will contain undetermined coefficients that we're going to have to solve for. But if g of x is a constant, then you should guess a constant. If g of x is a polynomial term, like x to whatever exponent or t to whatever exponent, then you should guess a scaled version of that polynomial term, plus all the other terms that follow it, or you could think of it as all the other derivatives of that term. Essentially guessing the full polynomial. But if g of x is a exponential, then you should guess a scaled version of that exponential with the same exponent. And if g of x is sine or cosine or a sum of sine and cosine, then you should guess a constant times sine plus a constant times cosine. And these are the three major classes of non-homogeneous terms you'll see: polynomials, exponentials, and sinusoids. And we know that if you have a sum of any of these like particular classes, like an exponential plus a polynomial term, then you should guess a sum of the appropriate guesses, like a scaled exponential plus a scaled polynomial. For example, if our g of x, let's just say that was x squared plus e to the 2x, in which case we should probably guess a full polynomial, ax squared plus bx plus c, plus a scaled version of an exponential, d times e to the x. Oops, 2x. And then we'd plug this into whatever differential equation we have and solve for the undetermined coefficients. But let's try something new now. Let's first go back to the differential equation we've been working with. Second derivative minus first derivative minus 2 times y. What if that is now equal to x times e to the x? Here we have a polynomial term multiplied by an exponential. So how do we solve this? Well, first of all, we should first rewrite our homogeneous solution. c1 e to the 2x plus c2 e to the negative x. Now, let's try and guess a particular solution. Since this has a polynomial term multiplied by an exponential term, let's try out the appropriate guess for a polynomial term times the appropriate guess for an exponential term. In other words, let's try out the particular solution, a times x plus b, all of that times e to the x. So let's just see if this works. So let's take some derivatives. Yp prime, that's just using the product rule, the derivative of the parentheses term, that's just a times e to the x, plus this parenthesis term, ax plus b, times the derivative of e to the x, which is just e to the x. And I'm just going to simplify this by factoring out an e to the x, so we get a plus ax plus b. Now let's take the second derivative, yp prime. That's just the derivative of this, so that's going to be a times e to the x plus, using the product rule again, a times e to the x plus a times x plus b times e to the x. And we can simplify that again as just writing as e to the x times 2a plus ax plus b. Now let's plug all of these into the differential equation, and we get the second derivative, e to the x times 2a plus ax plus b, minus the first derivative, a plus ax plus b, minus 2 times ax plus b times e to the x. All of that is supposed to be equal to just x times e to the x. And if you notice, every single term has this exponential term, so let's just divide by that, and let's factor out whatever's in front of these parentheses, and we're going to get that on the left-hand side. We have 2a plus a times x plus b minus a minus ax minus b minus 2ax minus 2b. All of that is supposed to be equal to x. So now let's simplify. Here we have plus b and minus b, plus ax and minus ax. Here we have 2a and minus a. So we eventually get that negative 2ax plus a, this a right here, minus 2b. All of that is equal to x, and I'm just going to say x plus 0. Which means that negative 2a has to be equal to 1, or that a is equal to negative 1/2, and that a minus 2b has to be equal to 0. And if a is equal to negative 1/2, that means that we get negative 1/2 minus 2b is equal to 0, or b is just equal to negative 1/4. Which means our particular solution is yp is equal to negative 1/2 x minus 1/4 times e to the x. And the general solution would just be this plus this homogeneous solution here. There we have it. We found that if you have any one of these three classes of non-homogeneous terms multiply by each other, then you should do the appropriate guesses multiply by each other. Likewise, let's just do one quick example. Let's just not solve it, but if g of x was just x cubed times e to the 2x, then we should probably guess that yp is equal to ax cubed plus bx squared plus cx plus d times e to the 2x. And if we multiplied this by like a sine, times sine of x, then we'd have to multiply by a sine of x plus b cosine of x. Well, I probably shouldn't use a and b, e and f. And that would be really tricky, but this would probably be the method you'd use to solve it. So, hopefully that was fairly straightforward. We're going to continue on and talk about what happens if your particular solution overlaps with your homogeneous solution in the next video. So hopefully see you then.